All right, I'm going to talk some more about this formal definition of a limit, and I'm going to write what the formal definition is here, and I'm going to give a what I think is a pretty decent real-life explanation of where this is used. So here's my formal definition of a limit. It says the limit as x approaches some number c of the function f of x equals L. What that means is that for every epsilon greater than 0, there exists a delta greater than 0 such that if 0 is less than the absolute value of x minus c is less than delta, then the absolute value of f of x minus the limit is less than epsilon. Right? So again, what this is saying is the distance. The distance, remember this is a distance, it's greater than 0, it's less than epsilon. So how far we are from x, that if there's a delta greater than that, then there's got to be an epsilon that's less than this distance, f of x. And I'll show you about what I mean by that. And so here's my real world application. Let's say there's a factory. And that factory is along a river. And the name of this river is River Charles. And what it does is in its processing, it dumps a toxic waste into the river. And if it was a high concentration, it would not be good for living organisms. And over here I have a town. I'll call it Charles City. And by the time this toxic waste, it enters the river at a certain level that by the time it gets down here, the toxic waste is so diluted it doesn't have any harm to any of the residents or anybody that's using this water, since they're using this water to cook and drink and wash their clothes and everything. So over here they have a meter. In that meter, they have what's considered an acceptable limit of, parts per million. I think they call them ppm. And if it's there, then it is safe. Well, the water varies as it goes down the river, and so hardly ever is it at this L. Sometimes it's a little bit below it, and sometimes it's a little bit above it. So it has a tolerance level. Of so many parts per million above the level and so many parts per million below the level. And that tolerance level, I'm going to call that give on each side, I'm going to have, I'm going to call it epsilon. So I have L minus epsilon, that's below, and L plus epsilon, oops, got to write it the right way. And we've got to be somewhere in between here. Okay? And notice this is an output. I mean, we're inputting into the river, and lo and behold, we get an output right here. And so I can write this as a functional notation. So this can be considered a distance, and because it can be considered a distance, I can say that actually if I subtract L from both sides, I have a negative epsilon below, and I have f of x minus that limit is less than epsilon. So since it's a distance, I can use my absolute value symbol and say that that's got to be less than epsilon to be safe. All right, so what's coming here is f of x. I have a limit. The difference between my safe limit and what I'm actually getting into the city is epsilon, and it's got to be within that epsilon. And over here I have a meter, and it's a dispensing meter. It's what's getting input into the water. The function f of x is what's that function of diluting this toxin as it goes through the river. Because the river does clean itself. It's just that we, as an organism, don't want to raise it above its cleaning ability. And so it has an x amount that it dumps in that it's trying to maintain. Well, that's going to vary also. It's going to be a little bit above. Excuse me. I want to call that a C. It has a C right here. And that is its ultimate goal. Well, that's going to vary a little bit. So it's going to be a little bit less sometimes. It's going to be a little bit more sometimes. And that distance, I'm going to say, is delta. So what actually happens is I'm going to have an X amount. I'm going to have an X amount here, or I'm going to have an X amount here. Well, it's so much delta away. So what's really being put into the water is X. This is how much I should be putting in, but they're not always going to match up. And again, it's a distance. The distance between what actually is going in, X is actually going in, actual toxin amount, and C is my ideal amount. And so this is going to be, since it's a distance, the absolute value, and I want it to be less than delta. So as we're monitoring this, if I ever go over epsilon, what I'm going to have to do is I got to reduce my X so I'm in this acceptable level. So I stay within, try to get as close to the limit that I'm allowed, that the city of Charles City allows me to have. Because if I go beyond that, I'm going to have to change my X and get it back so it's within that delta. That's the that is the application of this formal definition of a limit.